start the class today. Does anyone have any questions for me? Anyone have any questions for me? Again,
Yes.
I'm sorry, Corinne. Yes.
Yes, I have a question, Professor. I want just, it's not like a question. I want just to make you know that the last record, the record we did on Thursday, I think it was a bit blurring.
A bit what?
I don't know if, yeah, it's like flu. It's not very clear. I don't know if some people, I don't know if it's my computer or some people notice it. When I was going through the record to study and do the homework, it was not very clear to me. Like I couldn't like see all the part. I don't know if it's my computer. But I tried another computer. It was the same thing.
Okay,
So,
I will check back the recording and see what it looks like. And then if it does, then I probably have to maybe I will record it, or maybe I have to find another old video to replace it.
okay, thank you. That was my
Yep.
question. Thank you.
Yep, Corinne. Yep. Thank you for letting me know, because I didn't know it, because I did upload it. I didn't watch it, but I will definitely will watch it and see. Thank you. Anyone has any questions? All right. So so we're gonna finish up with the last section today here. 3.3. So we talk about the measurements of location, outliers, and also box plots in this case. So the first we talk about is the z-scores. So the z-score in this case is called a standardized value, where it measures how many standard deviation away from the mean. The formula to calculate the z-score in this case is the z-score formula is the value minus the mean over by the standard deviation. This is actually your fifth formula so far that you need to know. So this is all the formulas that I written down here, and I will keep on updating this list here. I think the first test, I think you have around like 8 or 9 formulas. But as I mentioned, you're allowed to use one front page of note in your test. So make sure you guys transfer this into your one front page of note here. Okay. So I give an example last time. How do we calculate z-score? Let's say that you took a test. The mean is 72. The standard deviation is 6. And let's say your test score is 90. You have to figure out what is the z-score in this case. In order for you to do the z-score, you take the value, which is the 90 that your test score is, minus the mean, which is 72, divided by 6. You find out that z-score in this case is 3. Okay. So so this is how we figure out the z-score, how we apply this formula here. Then we figure out what is this z-score used for. Okay. So here are some examples of what the z-score is used for. One, make sure you know that z-score has no units. Okay. That means that this 3 that we calculate in the example has no units. Okay. The only units if you want to use for a z-score is the number of standard deviation. So if you do want to figure out the units, the unit is how many standard deviation. So for example is if you find out this z-score, the example that we have is 3. This is 3 standard deviation. What does that mean when I say it's 3 standard deviation? It's kind of like back to the empirical rule. So this is 0, this is 1 standard deviation, this is 2, and this is 3. So 3 standard deviation is somewhere on this location on here. Okay, again, I mentioned about location here. So that's the reason why that the 3 the value, either you give no measurements or you use a standard deviation. Okay. Now, the next property of z-score here is the data value is significantly low. So this is talking about you can also use z-score for outlier case. Okay, again, the word significantly means outliers. So if your z-score is less than or equals to -2, then it's considered significantly low. If your z-score is higher, greater than 2, +2, then we call this as significantly high. So again, we use -2 and 2 due to the ROROT, the one that we just did on the 3.2. So the ROROT where we use a plus minus 2, whereas the 2 stands for the 2 z-score. That is kind of the cutoff value to figure out the low and the high outliers. So we're going to use that, the same thing here. And then the third property is saying that if you can have a negative z-score, means that your value is below the mean. Okay, so if your z-score is positive, means your value is above the mean. If your z-score is negative, means your value is below the mean. If your z-score is 0, means the value you have and the mean is exactly the same. Okay, so these are your 3 properties here, and I will add one more. The fourth one is the unit that I just forget to put in here. The unit that we will use here, if it can be using standard deviation, but it has to be positive because standard deviation can be negative. Okay, so what is the last property of the z-score here? The fourth one says here is that as you guys know that z-score has no units, but if you want to use the standard deviation as the unit, then make sure that you cannot have a negative value in this case, because your z-score your summation cannot be negative. Example, what do I mean by this number 4 example? Example is like, let's say that your mean of the test is 72, example that we just did here. Your standard deviation is 6. Your test score is, let's say is, now we do below the mean. So let's say you got 65, which is we know. So the question is, what is the z-score? And then what is the z-score in standard deviation? Okay. So so this is very tricky because last time we just asked you for the z-score. So that's why we do not need to worry about negative or positive, because z-score can be negative, z-score can be positive. However, for this question, they ask you for the z-score in standard deviation. So we use back the same formula that we just find, where you take the value, which is 65, minus the mean, 72, and you divide this by 6, which is the standard deviation. Then again, use a calculator here. 65 take away 72. And then divide this by 6. So your z-score in this case should be negative 1.166666667. So this should be negative 1.16667. Unfortunately, we cannot use this as the answer here because in standard deviation, it has to be positive. So the answer in this case should be just 1.1667. So make sure you guys understand about if a question want this in a standard deviation, or they just want it as no units. If it's no units, then your answer will be negative 1.1667. Otherwise, it is 1.667 if it's in standard deviation. You will see the first example later on about this question that I mentioned. Okay. We'll talk about the percentiles and quartiles, and then we'll do some examples. Percentiles is where the measures of location. Percentile usually is denoted by P1, P2, all the way up to P99. This is where you break your data set into 100 groups, and then each 1% will break it out into each group into 1%. Per group in this case. The lower the percentile, the worse it is. So let's say if your test score, I say, David, your test score is the first percentile. That's bad news because you are the lower, David will be the lowest test score in this case. Okay. How do you find percentiles? You find percentile using StatCrunch. So in StatCrunch, okay, do you remember the same? You go to the summary stats, the same column, and then right under here that you do the Control A. Remember the Control A? Okay. Then right underneath here, this is where the percentile at. Okay. So I'll show it to you. Where is it in StatCrunch? So you will see it. So in StatCrunch, so if you go to the stats, summary stats, and column right over here, this is where your Control A here. So it's right underneath the Control A, the statistics. Okay, do you see the word percentile underneath it? So this is where you put your percentile. So if you want to find 30th percentile, you just put 30. If you want to find more than one percentile, you want to find the 30th and the 85th percentile, then you just put 30 and comma with the 85. The more, you can put multiple percentiles here. So make sure you guys know that percentile is right underneath the statistics. Okay. Make sure a lot of students ask me in the test, I'll tell you where is it at. So make sure you guys know where is the percentile located at. Next, quartiles. Quartile is where you break it into 25%, like quarters. So we only have 3 types of quartiles: Q1, Q2, and Q3. Where Q1 in this case is the same as the 25 percentile, means that it separates the bottom 25% from the top 75%. So that means you are on the 25 percentile, the first quartile we call it. The second quartile, Q2, which is also called as the 50th percentile, which is also called the median, is where you separate the data from the bottom 50 to the top 50 as up is median. So exactly in the middle. And the third quartile, Q3, is the same as the 75 percentile, means that it is separating between the bottom 75% to the top 25%. So these are the quartiles here. So the only why you need to know the quartiles is, again, its location is because of IQR. Because don't forget, IQR, if you remember the formula here, which is number 3, IQR is the third quartile minus the first quartile, Q3 minus Q1. Again, you do not need to worry about that because your StatCrunch will give you the quartile in this case. So the same thing when you do your, once you hit your Control A here, you will notice that there are Q1 and Q3 in the statistic here that you find, and then the Q2 is not here because Q2 is the same as median. So median is your Q2 here. So make sure you guys know that once you hit the Control A here, you will take care of your quartiles in this case. So this is how we do the location. The first 3 of these are location. So does anyone have any questions for me with these 3 locations? All right, so then we talk about the 4th one. This is not the location. This is the box plot here. So I use a different color. So now we talk about what is a box plot and what is a box plot looks like. It's a box plot actually require you to know your 5-number summary. So what is a 5-number summary is? 5-number summary consists of 5 numbers. Minimum is the first number. First quartile, Q1 is the second number. Median is the third number. Q3 is the third quartile is a 4th number, and max is the 5th number. So it'll be minimum, Q1, median, Q3, and maximum. So this is your 5-number summary in this case. And again, you do not need to worry about how to find the 5-number summary, because if you do your Control A, it will have all your 5-number summary where it has your median, you have your minimum, you have your maximum, you have your Q1, and it has your Q3. Okay, so this is your 5-number summary that you do your Control A. So in other words, once you hit Control A, you probably will cover everything up in chapter 3. Okay, your 3.1, 3.2, and 3.3. Okay, so so what is useful for this 5-number summary? This 5-number summary is used to draw a modified box plot. Okay, so what is a box plot? A box plot consists of the 5-number summary. Sometimes called a box and whiskers diagram, because if I want to draw it out, it will look like this. This is what a box plot looks like. So a box plot will have a box, and then it has what we call as a whiskers. Okay, so this is what we call as a modified box plot. This modified box plot will consist of this 5-number summary, where the most on the left side here is your minimum, and then the way on the far right side here is your max. Okay. And then, as you guys know that 5 numbers require you to know the Q1 and median and Q3. So inside the box, the beginning of the box is your Q1. In the middle of the box is your median. Okay, and then in the very end of the box is your Q3. So this is what a modified box plot will look like, where it does consist of 5-number summary that we just talked about here. And then it has a whiskers to go to the minimum and the whiskers on the other side to go to your maximum. Okay. What is this box plot used for? The most important thing is to this modified box plot is used for is 1, it is identifying outliers, and 2, it can tell us is your data is skew left or skew right, or sometimes symmetrical. Okay, so so your box plot can tell us either the skewness on the left or skewness to the right, or it can tell symmetrical. However, a modified box plot cannot tell a normal distribution. Okay, so you cannot do the normal distribution for box plot in this case. So please make sure you guys know that only can tell either it is symmetrical or it is skew left or skew right. For example, if a box plot that you get or you from StatCrunch, you can draw it. Actually, StatCrunch will draw it for you. If you look something like this, then this one says it has no outliers, and this is symmetrical. Okay, you cannot say it's normal. Although symmetrical means that if you cut in the median right in the middle here, the left side and the right side is kind of roughly the same. Okay, so that is what we call as symmetrical in this case. Again, you cannot say normal distribution. Now there is another type of box plot. Also, I will show it to you what it looks like. So we have a box, and then we have the whiskers, the left and the right, and sometimes we have dot like this. Okay, so once you see dot like this, those are your outliers. This kind of dots are your outliers in this case. Okay, so so that's the reason why that box plot, modified box plot, is a perfect box plot to use, especially if you want to figure out outliers. They will show you a little dots in the end there. Okay, so your minimum is still on the very far left in this case. Your box is still having Q1, median, and Q3, the same as what we have here. The box is always your first quartile, your median, and your third quartile. However, the maximum, if you have a outlier here, your maximum is the very last number. In this case, your outlier on the far right here. Okay. Then what is this dot? This dot will be your second highest number. And then this one is your third highest number. So this is how the box plot will look like. On the right side, if you have any outliers, the maximum is on the way first dot on the right. And then the one next before the maximum outlier dots here will be your second highest value in your data. And then this will be your third highest value. Okay. So how do we do this? How do we have an how do we interpret this kind of outline this box plot is it does have two outliers and it actually skewed to the right, right, skewed to right. Okay, so because so this kind of box plot will be have two outliers because it's on the two outliers on the right hand side here. And the skewness to the right is because you find out that these two dots, the outliers, push it to the skew to the right. And then we have another one that if having something like this. So if you have this kind of box plot, then you have only one outliers. And it's skewed to the left. Okay, so in this case, if you have a box plot look something like this, you do have one outlier which is on the left side, and it is skewed to the left in this case. So you can actually plot multiple box plots here. So you can plot two or more, and you can compare the box plot in this case. Okay. So you can draw like male and female box plots and compare, who is smarter, who is, this and that. So you can compare two or more. You just compute two of them side by side. Okay? And make sure you guys know that every time when you interpret your box plot, make sure you interpret it using CVDO. And how we interpret using CVDO is right here again in green on the formula piece here. So this is every time when you hear the word CVDO, this is how we interpret it. So so I'm going to put it down here, interpret. So make sure you guys know how to interpret your box plot. Again, you look for outliers. If you have any outliers, we will use only the median and the IQR. You don't give me your median, any other else statistics. But if you do not have any outliers, you will use the mean and the standard deviation. This is very important. So this is usually how we interpret your box plot in this case. So how do you draw a box plot? Let me show it to you. So because I don't have any data, so I'm going to get a data set here. So you can see it so I'm just use the first body data set here. So you go under graph, and then you go under box plot. Okay. And when you go to box plot, you will pick variables. Again, you can do multiple. So I'm going to do let me see the white. I don't know. I think it's a white. Maybe do BMI. Just do BMI. I just pick one. And if you and then you hit compute. If you do that, then you will get your box plot that is in a vertical way. And again, those dots are outliers. But if you want to draw your box plot horizontally, then you just have to check on these two options here. So make sure those students who are doing this for the first time in your StatCrunch, make sure the options here you have to check. The first option is to identify outliers. If you don't check this, you don't see those dots at the end there. And then the other box you have to check is to draw it horizontally. So this will be your modified box plot in this case. If you are lazy to count how many dots in there, just hover your mouse towards the box plot. They will tell you that in this case, there are 14 outliers here. But then you say, hey, David, wait a minute, that's not 14 dots in there, right? If you really kind of look at the dots, that's not 14, that's like maybe 8 or 9 dots, right? The reason why there are 14 dots outliers here and you only have 8 or 9 dots is because some of the outliers, some of the dots here share the same point. Example is, we know that some of this point is your 59. So there's only one, let me see. There should be some that have multiple outliers here. Example is maybe this number 48 has 2 rows, okay? So what happened is that means you got 2 data that have a BMI 48. However, they only give 1 dot because they share the same dot in this case. So the best way for you, if you have this box plot drawn using StatCrunch, just hover the mouse over here and then they will give you the outliers here. So that is how I will tell my students when you do your test and your homework. The StatCrunch will draw it, the picture, you just need to figure out. So the IQR is also given to us. And then the only weird thing is that the 5-number summary in the box plot here are not the 5-number summary, because the lower limit and the upper limit is not your minimum and maximum. Let me repeat. The lower and the upper limit is not the minimum and the maximum. As you know, that 5-number summary needs mean and max, Q1, median, and Q3. But what is lower and upper? The lower and upper limit that you see here is the line. So this line is if you look at this line will be actually at 15.9. And then this line, which is the upper limit, is going to be at 43.2. So this line only show us the lower and upper limit just only show us how far the whiskers goes. They don't give us the mean and max. So make sure you guys know this. This is very important. Where do you find the mean and max? I will recommend you to go to the stats, summary stats, and column. We do what the BMI and the control A. This control A will give us the mean and the max. So 15.9 is the mean, but unfortunately the max is 59. So it's a little bit different from the 5-number summary that they don't give you the 5-number summary. They only give you the lower and the upper limit in this case. Okay, just want to point out to you guys so you guys don't get these two mixed up here. Anyone have any questions so far with the 5-number summary and the modified box plots? All right, then we got the last one here, outliers. Now this is important because as you guys can see that there is what I call you to memorize all these formulas. So there are actually a few of them. So I will bring it up again for you guys here. So what is outliers? Outliers is where the values are far away from the rest of the data here. It is very important for us to identify and consider what is considered outliers here. And some of the outliers can affect your statistics, like your mean and your standard deviation is affected by outliers, right? So the only statistic so far that you learn in this class that is not affected by outliers are your median and your IQR. So the one that you just see me here, this is why we use outliers. If any outliers we use this is because these two statistics is not affected by outliers, but the rest of the statistics you learn so far that you have seen in here, they mostly everything you see here all are affected by outliers in this case. Okay, so that's the reason why that I will say we will need to know how to identify them and need to know why you need to do those. Okay, so there are 4 ways for us to identifying outliers. Yes, there are 4 ways. Depending on what kind of the questions provide, what kind of information is provided in the question. Okay, so make sure you guys know which is which. Okay, now if the question only provide us the 5-number summary, then we will use these fences where that you have to use 5-number summary will be the one that we just mentioned, the minimum, Q1, median, Q3 maximum. Then the upper fence will be Q3 plus 1.5 IQR. The lower fence will be Q1 minus 1.5 IQR. And any value that is outside this fence then is considered outliers. Okay. So let me give you this 5-number summary. So it's very different from the ROT that you guys use. So if you remember the range of rule of thumb that you guys use, we do take the mean plus minus 2 times the standard deviation. However, for this 5-number summary, we don't use that. We don't have mean and standard deviation, so we use the Q3. So for the lower end is Q1 minus 1.5 times IQR. Okay. And then for the upper fence, we will use Q3 plus 1.5 times IQR. So this is kind of like the RROT, but again, we only use 5-number summary here. And do not forget that IQR is the same as Q3 minus Q1. Okay. And any number that falls on the left side of the lower fence is considered the low outliers. And any numbers that data that falls on the higher than the upper fence, then it's a significantly high or upper outliers, higher out. And if your data falls in between the middle, is no outliers. Okay, so this is using the 5-number summary. Okay. Now, the next one is if the question is given us raw data, then you draw the box plot to figure out outliers. So if a question is given us raw data like this, you don't use the 5-number summary, don't use the RRT, just go straight to your StatCrunch and draw me the box plot. If your box plot shows something like this, means that it does have outlier. Let me show you a box plot that it does not have outlier so you guys can see it. Maybe H might be, let me see. Yeah, sorry, I need to go the other way. So if you have something like this box plot based on the age, then you do not see any outlier, and it is kind of symmetrical. You can tell that right in the middle here, you've cut it right over here. So the right and the left is somewhat symmetrical. So this is considered symmetrical, and also no outliers. Okay, compared to the one that we just did just now for the box plot BMI here. This has multiple outliers and is skewed to the right because those outliers push it to the right. Okay, so that is what happens if you have a raw data. If you want to figure outliers or not, just draw a modified box plot. That will be a fastest way for us to figure out outliers. Okay, what happens if a question gives us the mean and standard deviation? Then we will use the RROT. So mean plus minus 2 times the standard deviation. And I'm going to highlight this in another color so you guys will see it that this is going to be, I'm going to change it. So you guys can see that I'm going to, yep, this is very good. So if a question is going to give us mean and standard, then we will use a range of rule of thumb where you take the mean plus minus 2 times the standard. So I am going to show it to you. What's the difference? So a lot of students get these two confused. The blue one that you see highlight is using 5-number summary. The one that is using red is the range of rule of thumb, where we will use the median minus 2 times the standard deviation, and the median plus the mean, sorry, plus the 2 times the standard deviation. So again, a lot of students get confused between using the range of rule of thumb and also using the 5-number summary, because the 5-number summary, we use the number 1.5. But if you use the RROT, you use the number 2, plus minus 2. So a lot of students get that a little bit confused here because of that. They switch them around and then you get it wrong. Okay, so I think we talked about this before in your previous section. And again, any number that falls below or above is considered low and high. Anything falls in the middle is not considered high. And the last one is if a question is given us the mean, the standard deviation, and a value, then we will use the z-score. Okay, so these are the 4 ways for us to figure out outliers, and it depends on what the question provides to us. Okay, so some students will ask me, David, the question gives us 5-number summary and also the question gives us mean and standard deviation. So can I use, which way should I use, number 1 or number 3? Well, if a question gives you these two 5-number summary and also the mean and standard deviation, then I will say up to you. You can use number 1 or you can use RROT number 3. No matter which way you pick, you will still end up to be the same answer. Okay, so let me transfer all this into my formula because as I mentioned, you have to memorize this. I am going to use purple here for number 6. Okay, so this is figuring out outliers. So it's quite important here. Okay, so I'm going to draw the picture here. So on the same picture that we just draw just now, you can use Q1 minus 1.5 IQR. So you're multiplying it. And then Q3 plus 1.5 IQR. So this is where I give you the 5-number sum. So this is 5 numbers. I just use 5 pound here. So, or hashtag. Okay. And then I'm going to use a little blue here. We're going to use the ROROT. So ROROT is where you use the mean minus 2 times the standard deviation, or mean plus 2 times the standard deviation. And then any number that is below or above it. So this is called significantly low. And this is called significantly high. And this is considered no significant. Okay. So this is how you figure out outliers. So you can also draw a modified box plot. Okay. This is only used if you have outlier, if you have raw data. So if I call you to go to data set number 10 or data set number whatever, if I give you the raw data, then I will say modified box plot. The last way we can do here is to figure out outliers is using z-scores, which is the one that we just mentioned in number 5. Make sure you guys know that if you use z-score, if your z-score is above 2, then it's considered high. If your z-score is below -2, it's considered low. Okay. And if your z-score is in between a positive 2 and a -2, then it's no. So if your z-score is in between -2 and 2, then it is no. So this is how you figure out outlier case if you're using z-scores. Okay. Question so far with chapter 3 is a lot of work here. And you figure out it's not that easy anymore. Questions? Right, we'll look at some examples so you guys know what we are doing here. So the first example is Bao is the world's shortest man with a height of 21.5 inches. Men have height with a mean of 69.9 inches and a standard deviation of 2.8 inches. So the question is given us the mean, the standard deviation, and also a value, which is a Bao's height in this case. So you can tell that this question is like number 4, where they give us the mean, the standard deviation, and the value. So that means usually they will ask to find the z-score in this case. So question A is asking us find the difference between Bao's height and mean height of man. So if you want to find the difference, means you have to subtract it. So Bao's height is 21.5, and the mean height is 69.9. So in this case, you have to subtract these two. Again, calculator will help here. So 21.5 take away 69.9. So your difference here is -48.4. Okay. And the reason why your answer is negative, not a positive, is because his height is below the mean. He's the shortest man in this case. Definitely his value, his difference is be a negative. Okay. B, how many standard deviation is found in part A? So this is kind of like asking, if you remember the z-score, they're asking you for the standard deviation. So in this question is you have to find the z-score but then make sure that it has to be a positive. Okay. And then if you look at question C, they ask you to find the z-score. So I will tell you that since the question asking for B and C, so this is exactly the same. The only difference here is, this is very important. A lot of people make mistake here. So part B and C are the same. The only difference is in part B, make sure it is always positive. Okay. So that's the only I will point out. So we're gonna do part B and part C together. So in part B, you still need to find the z-score. So the z-score in this case is you take the value minus the mean, parentheses, and then divided by your standard deviation. Okay. So so the value is 21.5 minus 69.9, and then you divide it by the standard deviation of 2.8. Okay. So what you do is, perform this in your calculator. So 21.5, take away 69.9, and then you divide this by 2.8. Now this value came out to be negative 17 point something, 17.29, negative 17 point, oops, sorry, negative 17.29. However, because this is measured in standard deviation, because this is measured in standard deviation, it has to be positive. So the answer in this case is positive 17.29. So in other words, if they ask you for the standard deviation, just take the absolute value of the z-score. Okay. C, we just did it already. So for part C, you want to find the standard the z-score. The z-score is negative 17.29. Okay. So that's the difference between question B and question C. So make sure you guys know this. Okay, so a very important case. Now, where is Bao's height? If you look at this, his z-score is negative 17.29. So do you know how far is his value is? Don't forget, right in the middle is 0. If you look at your RROT, this is negative 2. So if you think about where is Bao height is, I would say that Bao height is somewhere over here, where is negative 17. So negative 2, negative 3, negative 4, negative 5, and then you continue going. That's how far he is. So the question is asking is his height being significant? Yes, if you're asking for significant, if you remember what we just did in the formula here, so anything that is below negative 2 is considered significantly low. And his z-score is negative 17.29. So definitely it is a significantly low piece. So the answer in this case is yes, this is so. His z-score is way below than that equals to negative 2. So it is significantly low. Okay, so yes, so when he comes to class, everyone will look at him because he is just like a yard long. Okay, really short guy. Okay, so so that's the reason why that it is significantly low in this case. So this is how we do question number 1. Anyone have any questions for me here? Okay, question number 2 this is where the question is provide us the 5-number summary for the temperature in Minneapolis. You're asking for, is there any outliers in this case? Support your answer in this case. Now, since the question is provide us 5-number summary, so we have to use number 1 because that is where the 5-number summary is for. Okay, that means we have to use this formula. We cannot use the box plot. You cannot draw a box plot because the question did not give us the raw data. And you cannot use the ROT because the question did not give us the mean or the standard deviation. And so the question can also use z-score. So you have to use the first one. Okay. So this is something that I will point out. Quite important here. So if you remember that if you use the first one, you need to find the IQR first. So this is the same thing. You have to find what is IQR first. And IQR in this case is Q3 minus Q1. And Q3 is 49. Q1 is 38. So if you subtract, it's become 11. Okay. And what we're going to do next here, class, is to give me your picture here, because again, the picture means a lot to us. So you will use Q1. I'm going to type. I'm sorry, I'm going to type in this because it's going to be faster for me to type. Q1 minus 1.5 times IQR. Okay. So Q1 in this case is 38 minus 1.5 times IQR. IQR is 11. So you might need to use a calculator here to figure out what is 38 take away. Okay, this is 38 take away 1.5 times with 11. So you came out to be 21.5. Okay. And you do the same thing on the higher end. So the higher end in this case is Q3 plus 1.5 IQR. So on this higher end is where you take the Q3 plus 1.5 times the IQR, where Q3 in this case is 49 plus 1.5 times the IQR, which is 11. Again, calculator in this case, 49 plus 1.5 times 11. That will give me 65.5. So that means that these two values is the cutoff values for being low and high. Okay, so this is how you figure out using the 5-number summary, the Q formula here. We're not done yet. So how do you know if there's any outliers? You look at your minimum and you look at your maximum. Because so you look at it. So this number should be 21.5. If you put this in the number line, this is 21.5. And this is 65.5. So where is the minimum located at? The minimum is 29. So 29 is somewhere here. So that means that this is good news for the minimum because 29 is in between the two fences here. So that means it is not significantly high. Then let's take a look at your maximum. Unfortunately, your maximum is, if you look at the number line, is 66. And 66 is a tad bit higher than the 65.5. Again, you cannot round this. So unfortunately, this one is an outlier. Okay. So how do we explain this? There is an outlier on the high side. Or sometimes you call it the maximum. Okay. So in order for you to explain this, it's very easy. You just look at your mean and max. If your mean is inside, no outlier. If your maximum is also inside this fence, that means both of them are inside. The mean and max is inside, no outliers. If your mean falls outside the 21.15 and the lower case here, a lower part here, then the minimum is an outlier. Same thing, maximum fall above the high side means it's an outlier, and it can be on both end, low and high. So this is how we explain this. If you have to do this, so make sure you guys use the 5-number summary ways to figure this question out. Anyone have any questions for me? Okay, we're going to continue with question 2. So for question 2, we are given 2 tests. One is an SAT test, has a mean of 15.8 1518 in the standard of 3.325, and the SAT score of 1490. It's pretty good, you know, with a pretty high SAT score. And now we talk about the ACT that I highlight in purple here. ACT has a mean of 21.1 with a standard deviation of 4.8, and you got an ACT of 17. So the question is asking which one is better. Okay, so so how do we figure out which one is better? If you want to compare two things, we will use the z-score. Okay, so a z-score means we try to convert this test score into a standardized score. Then you can figure out who did better. So again, how do we find the the z-score? If you look at the SAT one, so the z-score is calculated by taking the value, which is 1490, subtracted by the mean, 1518, and divided by the standard deviation of 3.25. So so this is how we figure out. So mostly if the question wants you to compare which one is better, usually they ask you to do the z-score in this case. So we're gonna subtract these two, 1490, take away 1518, and then close the parentheses and divide this by 325. So this z-score is negative 0.086. I put in 3 decimals here. So this will give me negative 0.086. Okay, so that is the z-score for SAT. Now we're gonna do the z-score for the ACT in this case in purple. Look at all these different colors now. So for ACT, the z-score is you take the value, which is 17, minus the mean 21.1, divided by the standard deviation of 4.8, the one in violet or purple in this case. And again, I use my calculator to perform this. So that will came out to be 17 take away 21.1, and then you divide this with 4.8. So that came out to be negative 0.854. Okay, so you got this two z-scores now, SAT and ACT. So the question is asking who is better. Okay, as you guys know that we want the higher, which is the better, right? So who is better in this case? You can tell who is bigger. So this is not a trick question. So you need to figure out who is the biggest one. And unfortunately, both of these numbers are negative. And you need to know this because the bigger the negative number, the smaller the value is. So does anyone know who has a better z-score, the SAT or the ACT? Who is bigger?
SAT.
Yes. So SAT's is better than the because the z-score for the SAT is higher than the z-score for the ACT. Because if you look at this, the SAT, this z-score is closer to 0. But if you look at the ACT, the z-score is closer to -1. Okay, so so that's why if you draw the number line here between 0 and -1, you find out that your SAT is somewhere here, and your ACT is somewhere here. Okay, and you notice that the SAT here is actually do better than ACT here. Questions, anyone? Make sure you guys know a little bit about, you know, your position of your number line here. So a lot of students get these two confused and they thought the ACT is better because it's bigger. But don't forget the negative, the bigger the negative number, the smaller it gets. Anyone have any questions so far with question 3? All right, so now we're going to do question 4. This is coming up in your test. So I want you guys to pay closely attention here. So make sure this is definitely coming up in your test. Okay. Before we talk about tests here, I do want to take attendance here. So please make sure you go ahead and do your attendance here. Okay. So, and then I want you guys to really pay close attention to the question 4, the very last question for this case, because it will be in your midterm next week. Okay. So the question says that you have to refer to data set number 21 about the Oscar winner. So the Oscar winning age. We will be doing how old is the actresses, just the actresses who won Oscar during when they, and how old the actresses are. Okay. So the question here is asking us to find P17, P90, Q1, and then they want you to draw a box plot where you have to include the 5-number summary and you have to interpret this. There's a lot of things you need to do here, class. So again, we only concentrate on the actresses. You had to find all these 3. You had to construct the box plot. And the box plot, you had to label your 5-number summary here and then interpret your box plot. And once you finish doing that, then you have to repeat this again for the actors one. So now you have to do this again for the actors, the guys. So you have to find all this, draw the box plot, 5-number summary, and interpret it. So we're going to do quite a bit of work here. So we will be doing actresses here on this side. Okay. All right. So what we do is we need to pull out this data set 21 from the from here. So make sure you go to StatCrunch, go all the way to data set number 21, Oscar. Again, we only concentrate on the actresses. And the first question they want us to find here is to figure out your percentiles. I'm going to split this into 2 screens here so I can. There you go. So, so how do you find percentile? Again, this is very important class. Go to stat, go to summary stats, go to column. Again, select actresses. That's where we need. You do not need to do Control A here because we do not need to find the mean, median, the standard deviation, and so on. We just need to find percentile. And class, where is the percentile at? It is right underneath that statistics, the Control A. And you are looking for 17th percentile, which is number 17. Comma, you need a 90th percentile. Now, since the question asks us to find the quartile 1, first quartile is 25 percentile. Okay, so you can put 25, which is the same thing as Q1. So make sure you put it right underneath here, separate by commas. And when you hit compute, so this is your answer in this case. And what do you notice is the 25 percentile and Q1 should be exactly the same because they are the same thing. Okay? So I need to move this a little bit on the side here. So so the 17th percentile in this case is going to be 27. The 90th percentile is 54, and the first percentile is first quartile or 25 percentile is 28. So this is how we find these 3 percentiles here. And then the question continue asking us to do the box plot. So you go under graph, go under box plot, hit actress. Don't forget to draw it horizontally, and you hit compute. So this is the box plot that you need to draw here, class. I'm going to draw the box plot. Again, when you draw the box plot, class, you just trace it. Do not need to be exactly, especially I asked this in your test. So mostly something like this. Just trace it out. And kind of like have 5 dots at the end. 1, 2, 3, 4, 5. That's it. This is what I will ask you to do in test. So you do not need to draw it out exactly the same, trace it the same thing. And now the question, once you finish it, you have to give me the five number summary. Question asking for 5-number summary. So you have to give me the 5-number summary. So this is how you give it to me. So let's go back to your Q1. So if you doesn't know what is your 5-number summary, just go back to your the result that you guys got early on here. Okay. So minimum is 21. So that is right here. Okay, 21 is a minimum. Q1 is 28. So 28 is the one that is the first opening of the box here. Okay. Right in the middle is your median. Median in this case is 33. Followed by your Q3, which is the one on the far end, 41 on the end of the box here. Okay. And the maximum in this case is 80. Now the 80 is not inside here. The 80 is this last follow dot here. This is 80. Okay, so make sure you guys know that 80 here is not the last one, the very end. So this is how you label your 5-number summary. I strongly suggest you do not use the 5-number summary given in the box plot. The reason why is because the upper limit in this case is not 80. The upper limit is 60. Again, what is upper limit? Is this line. Okay, this line is at 60. Okay, but that is not your min and max. Okay, so make sure you guys know this. So be careful with that. Questions with this before we continue how we interpret this box plot? Anyone? Questions? Very important features here. Right, now we're going to interpret. So how do we interpret this box plot is where you have to use your CVDO. Okay, so C stands for center, V stands for variation, D stands for distribution, O stands for outliers. So you have to give me these 4 features. And that's why in the test, this interpretation is worth 4 points. Okay, so how do we interpret? You look at, do we have any outliers or not? Since we have outliers in this box plot here, we got the dots. So you have to give me the median and the IQR. Okay, so for this question, you have to give me the median and the IQR. So, so we will say the interpretation in this case. The median is 33. It's from the StatCruncher. And the IQR, which is called the interquartile range, is, where was that? Oh, we don't have an IQR, but if you IQR is Q3 minus Q1, so you can subtract your Q3 and Q1. So 41 take away 28, that will be 13. Okay, so that will be 13. Otherwise, you can hover your mouse over to your box plot. They will give you the IQR right in that little yellow box there, the third line, so which is 13. So you can do it either one of those ways. So that is your C and your V. I just put it down here. This is your C, which is called the center. And the IQR is called the variation. Okay. And then the distribution. So the distribution is, so this distribution, if you look at the box plot, is skewed to the right. The reason why it's skewed to the right is because your outlier is on the right side. So, so it's skewed to the right. And a lot of students say that there are 5 outliers. That's an O part in this case. So this is your D and the O part is outliers because you see 5 dots in this case. This is where a lot of students make mistakes in the test. You are not 5 outliers, but David, there's 5 dots in here. But if you hover around here, again, the yellow box, you find out that there's no 5, there are 6 because one of those dots share 2 data. So make sure you guys know that. Don't just look at, a lot of students make a mistake by looking at the dots in the box plot and tell me how many outliers. So the best way is for you to just hover around and then just look at the yellow box in there. Okay. Another way is if you highlight, if you use a mouse and highlight this, you will find out that there are 6 rows in here. So there are one of the numbers here. You can tell that there are multiple. I think it's number 61, maybe. Yep, 61. So 61 came out two actresses are 61 years old, but you only have one dot here. Okay, so that's the reason why that they don't. So watch out for this. This is something I will say be careful with. Okay. So this is how we do this this whole features here. And as I mentioned, is coming out in the test. So, and this kind of questions worth around like 10 points. So be careful with those. I will say that. So now, anyone have any questions? Yep. So, okay. So now we have to repeat this for the actors. So repeat this for the actors. So now we're gonna close all these things, and those who are not paying attention just now, make sure you pay attention now again. So now we're gonna concentrate on the actors. So in order for us to find the percentile, you go to stats, summary stats column. Now you highlight the actors and put in the percentile there. 17, comma with 90 and 25. That's the first quartile, 25 percentile. And you hit compute. So now we are doing the actors variables in this case. So percentiles right over here. So I am going to write this on the side here. There you go. So the 17th percentile in this case is 36. The 19th percentile, 90th percentile in this case is what is that gonna be? 57. And the first quartile in this case is gonna be 38. And you find out that the first quartile and 25% is the same because it is the same. Okay. So this is how you figure out the percentile here. Questions, anyone for me? Make sure you guys watch this video if you need help, okay, because it's very important. Next, we will draw the box plot. So you go to the graph, box plot for the actors. Make sure the options here, both of these options is checked, and you hit compute. So this is the box plot for the actors. So I just kind of trace it right here. So you just have one dot in this case. One dot somewhere. Okay, so this is the actors box plot, but you do need to label your 5-number summary. Again, do not look at the yellow box in here. Make sure you refer it to here. So the minimum is 29. So this is 29. Your Q1 in this case is 38, which is right here, which is opening of the box here, the starting part of the box. Median is the middle point, middle line here, 42. Q3 in this case is 50, which is the end of the box here, not the end of the whiskers, just the end of the box. And the max is, where's the max? Where is my max? 76 right here. So, right, again, 76 is the end part of this point. Got students put it 76 right over here. That is considered wrong in this case. So make sure you guys know how to label your 5-number summary in this case. And then now we have to interpret this box plot here. So again, how do we interpret CVDO? Now, since the box plot here does have outliers, so if this have an outliers, we're still going to use the median and the IQR. Okay, so for this case, so the median is right over here, 42. So the median is, which is the standard in this case, 42. And the IQR, which is the variation in this case. I just put variation. Is, again, if it doesn't know IQR, you can subtract the Q1 and Q3 or use the yellow box, 12 in this case. Okay. This is also skewed, the distribution is also skewed to the right due to the outlier. Okay, so on the right side. And let's see how many outliers we have here. Again, don't look at just the dot. There's only one. So there is one outlier in this case. Okay. So make sure you guys know how to do this. This is very important in this case. So make sure you guys understand this case here. Super important. It's coming up in your test here. And worth quite a few points. So this test is actually this homework 3.3 is due on next week, Wednesday, the 3rd. Okay. So next week, Wednesday, July the 3rd. That is where your homework 3.3 is due. Anyone have any questions for me here? I'm gonna save everything here so you guys can. Questions, anyone? With this section here? Before we start with chapter 5. Right. So we're going to continue with chapter 5 here. So don't forget our tests include 5 and 6. And your first midterm test is next week, Wednesday, March 3rd. So there's quite a few homeworks you have to do here, class. So make sure you guys are working on your homework in this case. Okay. Don't slack off here. So start working on your homework. So what is chapter 5 and chapter 6 is about? Both chapter 5 and chapter 6 are July 3rd, not March. July 3rd, yes. So both of these, if you look at this, it is all doing probabilities. So in chapter 5 and chapter 6, both of these are doing probabilities. So I think you kind of know a little bit of probabilities here. So in this chapter 5, we are doing the discrete type. Okay. And then when you do the chapter 6 is where we do the continuous type. Okay, so that's where the chapter 6 comes from. Okay. Again, let me tell you what is discrete first. So the discrete random variable in this case is where you get a finite numbers of values, or is a countable numbers, where if I ask you for the data, the answer in this case you give me is 0, 1, 2, 3, 4, 5. Example is for this discrete type is number of. If I ask you number of cars you have, number of credit cards you have, number of pens you have, number of people, then your answer is either 0, 1, 2, 3, 4, 5. It cannot have decimals in this case. Okay, so in other words, this one cannot, no decimals. Okay, so that will be the type of chapter 5 is about. So in everything you learn here is mostly countable numbers, 0, 1, 2, 3, 4, 5. For the continuous type is where you can have decimals. This is more towards like your height, weight, temperature, and so on. Test scores. Okay. So test score is a very tricky one. Depends on how the test score is. If a test score is just 0, 1, 2, 3, 5 without any decimals, then your test score can be in the discrete. But once the teacher mark the test and give you half a point or quarter points of using decimals, then it is going to be a continuous. But I will say test score mostly is continuous type because you can have a 0.5 or a decimal test score in this case. Okay, so I will suggest so if you have a continuous random variable, then chapter 6 is about it. Okay, so let's take a look at chapter 5 here. So we have a random variable. So what is random variable X stands for? A random variable X is where an outcome of a single numerical value of each outcome of a procedure. So outcome means the result. So what a result can get, and that is what we call as an X in this case, or we call it the random variable. Example of this case is draw a table. Usually a random usually you need a probability distribution. Probability distribution is a table that consists of the probability and the random variable by itself. Okay, so we are doing what we call as a probability distribution here. So this is your X and this is your PX. So a lot of students will figure out what is X and PX stands for. X is called a random variable and PX is called a probability. Now I'm going to short form this as R dot V. Okay, that's called a random variables, RV. And if you see anything with, if I do the word PX next to it, means that is for the probability here. Okay. Now, this X we can use for, let's say, number of, I don't know, number of siblings you have. Okay, so make sure that so how many sisters and brothers that you have. Okay, so that will be your X, and you cannot have decimals because, you know, and I'm not talking about step siblings, I'm talking about the, you know, siblings. Usually in a class, you know, face-to-face class, I always get this kind of data from you guys. I just call you guys raise your hand. And let's say that if you are the only child, no sister, no brothers, then you have no siblings in this case, so it's 0. And then 1, 2, 3, and let's say that I got let's say there are no, ask the classroom, how many of you guys have 4 siblings, and no one raised your hand. But I say, okay, who has the most siblings? And then one student raised their hand and say, I got 6 siblings. And that is the highest siblings we have. That means that student have 6 brothers and sisters. So you cannot jump from 3 to 6. I know that is no students having 4, no students having 5, right? So, but we have 1 students having 6. So you cannot jump. You have to have 4, and you have to have 5, and you have to have 6. And let's say that in this classroom, there are no students having 4 siblings. There is no students having 5 siblings. Then the probability will be 0 because there's no hands. But as you know that there are 1 student raised your hand that have 6 siblings. So this will be 1 out of, let's say, 14. Let's say I got 14 students in the classroom. Then I got 1 student raise their hand that have 6 siblings, 1 out of 14. And then I asked, how many of you guys have no siblings? Raise your hand. Oh, you are the only child. And I got two students raise their hand. So this is 2 out of 14. And again, 14 is the total students I have in the classroom. And then then drop your hand. How many of you have 1 siblings? Raise your hand. And let's say I count, I got let's say I got 4 of you guys having only 1 siblings. Okay. Again, this is just an example. Again, usually I do this in the classroom. It's hard to do it in the Zoom in this case. And then I will ask how many of you have 2 siblings. 2 siblings in this case, I got also 4 of you guys raise your hand. Okay, 14. And then how many of you guys have 3 siblings? Let's say you got 3 of them. 3 of you guys have 3 siblings in this case. Okay, 3 out of 14, and 0 and 0. So this is what, and then this whole table is called probability distribution. So a probability distribution is where you need to have a random variable correspond to its probability. Okay. So this is sometimes in the probability, they use the number or the symbol 0 plus. So do not use 0 plus in your test or your homework. Test is all right. Homework, no, because your computer doesn't understand 0 plus. Your homework doesn't understand 0 plus. What is 0 plus? 0 plus is a probability that is so close to 0, it can be considered to be 0. Okay. For example, this is also very important in your calculator. So if you take 5 divided by let's say 1 million. Okay, this one doesn't give you E. Let me give you another a bit more crazier so you guys will see. 5 divided by let's say no, sometimes no. Now sometimes in your calculator, let me show it to you so you guys can because you guys might get a little bit different answer here. So let's see if this one gives you the same thing. 5. I think this might. Uh-oh, I don't want you. Okay. Okay, so sometimes your calculator give you a weird number that is called the E. Okay, they will give you I cannot, this calculator, I thought they're small. Maybe I change it back to a normal stand. See if it give me. I just want to point out to you because some calculator shows still give you the zero. The E part. Okay, so when they give you the E, I can find calculator that. I just want to point because some students might get confused with that E symbol. So I just want to point out. Yes, there you go. So some of you has this symbol here. I have to show you what does that mean here. Okay, so just for your note, this is super important class because a lot of students doesn't know what is it. So calculator. Anyone know what is this stands for? When you see like 5E something like. Anyone?
It's the zeros.
Yeah. So we call this as a scientific notation. So in your calculator, if you get 5e to the negative 8, this is the same thing as 5 times 10 to the power of negative 8. So in other words, if you want to write this in zeros, in decimals, that means you should have, if you have negative 8, you should have 7 zeros after the decimal. So 1, 2, 3, 4, 5, 6, 7, and the 5. So the 5 is the 5 in front here. So this is a very, very small probability. So let's say you calculate probability. So this is a very small probability. So in your homework, you will say this is 0. But in your test, you will say this is 0 plus. Okay. Or you can say 0 also. In the test, you can say 0 or you can say 0 plus. And what is 0 plus stands for? Which is right here. So 0 plus means that your number is very close to 0. So like here, 0.0005 is very close to 0, but you can still use this is, so you can use, so we call it 0 plus. So how do so make sure you guys know how to read this in your calculator. You can see this E5e to the negative 8. This negative 8 means you have to move your decimals 8 times to your left, and you have to put in the zeros for that case. Okay, so very important piece here. Okay. Now, what is considered having what we call as a probability distribution? This is the last one we're going to talk about here. The requirements for you to have a probability distribution here is 1, make sure that every random variable x has its correct probabilities. That means that every x that you have here must have a px next to it. You cannot have a blank spot. So you cannot have a 7 and then you leave it blank. So you have to, every x has to have a px like what you have here. So they all has to have matching in this case. Okay. Next, the sum of the probability is exactly 1. So what does that mean in this case is if you take all this probability and if you add them, you should get 1. Okay, so when you add 3 over 4, 3 over 14, all this probability up, you get exactly 1. If you add them out, but you didn't get exactly 1, you get 0.99999 or 1.001, is still acceptable because of rounding. Okay, so this and the last, so like this case, if you add all this 1, you get 1. That is fulfilling number 2, second requirement. And the last requirement in this case is each probability has to be between 0 and 1. So like this, 2 over 14 is between 0 and 1. 4 over 14, 3 over 14, 1 over 14, even 0 over 14. 0 over 14 is. Now don't forget, look, if you look carefully with this symbol, it does have a little equal sign in this case. That means that it can be 0 and it can be 1. You cannot, including 0, including 1. So that means your probability is always between 0 and 1 included. So if you fulfill all these 3 requirements, then you get yourself what we call as a probability distribution. Okay. So this is how we do this type of questions to figure out are they probability distribution in this case. Okay. I'll go through a little bit here, just a little bit more. I don't need to teach you. So the next one is we're gonna start right after here. Population mean and population standard deviation. Now you do not need to memorize the formula here. Please don't memorize the formula. I do not want you guys to memorize any formulas, this kind of formulas in your test or even in your doing your homework. And yes, when you do your homework, they will use these formulas that I X it up. The only thing I want to point out here is the symbol we use here. We do not no longer finding the sample mean and the sample standard deviation like what you guys did in chapter 3. Remember chapter 3, we find the mean, we find the standard deviation for the price and for the magnitude. This is all sample. Okay, so these are sample mean, they're all finding sample. But what I want to point out here now, when you do the random probability distribution, you don't find the sample, we find the population mean, which is the sigma, a mu, this is called a mu, and the population standard deviation, which is called a sigma. So, when you find a mean assumption for a probability distribution, we are not finding for the sample, we find it for the whole population mean, the whole group. That means that I can find the mean and the standard deviation for using this. Again, where I get this probability distribution from, I get it from sample, I get it from you guys. But I can use that to predict the population of number of siblings in North Hennepin. Okay, so that means I'm not just talking about this class, I'm talking about majority of the classes. So if I go to another class, I can kind of figure out what is the mean and standard deviation if I just use your class as a sample in this case. Okay, so if I cancel all this, then where is it at? Okay, so the question is we don't use formulas, we use StatCrunch. Okay, so that's the reason why that we don't want you to memorize all this form. Okay. So we're gonna continue the rest here tomorrow. So that's the end for today's class. So we will. So anyone have any questions for me today?